Hi, Form 3 girls. This is our physics lesson. Today we come to the last part of this chapter, so please be ready with your textbook and calculator. In this section 3.4, we will introduce the graphical representation of the motion of a body, which is the speed-time graph. What is meant by the speed-time graph? That means we use a graphical method. Okay, this is the graph. The speed-time graph, a graphical method to show the motion of an object. For example, if the motion of an object is at rest, what should be the graph look like? Maybe before we start continues to discuss about the various graph, we can have a look of the motion first. In this animation, you will have a speed time graph. This is the velocity time graph, which is similar to the speed time graph of an object. So it is the speed time graph of this red car. So can you guess what is the motion of the car during the journey? Can you guess? So from this red line, we can guess the car start from a speed of about 15 meters per second, and the speed is keep constant throughout the journey, right? So can you guess what is the motion of the car? So we can take a start to see whether you got a good prediction or not. Yeah, it is the motion. It is the motion of the car. So you can see that if it is a horizontal straight line, the car seems to move with a constant speed. That means in the same period of time, it travels by the same distance. It is the constant motion, constant speed. Okay? How about graph 2? This one. It is not a horizontal line, it is a straight line with a positive slope. A straight line is sloping up. Okay? Can you guess the motion of the car? So you can predict at the beginning, at the start, it moves with a speed 5 meters per second. 5. And then the speed of the cars increase constantly and then increase to 10 meters per second in 5 seconds, and then up to 20 meters per second at 15 seconds, and so on. It seems that the cars move faster and faster. So we can click the start to have a look of the motion of the car. So it travels slowly at the beginning and then move faster and faster. You can say that it moves with a uniform acceleration. That means the car is speeding up. How about graph 3? Okay, the graph can be divided into two parts. You start with a very high speed, 20 meters per second. And then the speed getting smaller and smaller, and then becomes 0 at 10 seconds, right? And afterwards, it remains in a horizontal straight line at the place 0. Okay, what does it mean? Okay, maybe we click the start to have a look of it. At the beginning, it moves very fast and then come to rest at 10 seconds. And afterward, it stays at the same position. That means for the first part of the graph, the car moves slower and slower and then comes to rest at 10 seconds. Afterwards, it stays at rest. So if an object stays at rest at the same place, the graph should be a horizontal line which touch the time axis, the horizontal axis. Is it okay? Okay, for graph 4, whoa, this part, they are quite complicated. For the first part, and second part, and the third part, and the last part of the graph, they are different from each other. Maybe we can take a look of the first part of the graph. At the start, it moved from rest, so its speed is 0 at the beginning. And then it moved faster and faster, and then becomes 10 meters per second at time t equals to 5 seconds. Is that okay? How about the second part of the journey? Right, it is a horizontal straight line. That means from 5 seconds to 9 seconds, it moves with a constant speed, which is equal to 10 meters per second. And how about the rest of the graph? Okay, its speed decreased from 10 and then to 0 at 14 seconds, and it stay rest in the rest of the journey. Okay, so we can take a look of the motion of the car. So it start from rest and then move faster and faster and constant, and then become 0 and then stay at the same position. So it is a bit complicated. Uniform acceleration at the beginning, and then constant velocity in the second part, and then decelerates to rest in the third part, and then stay at rest in the last part. Okay, so the graph can be divided into 4 parts. How about the rest of the 2 graphs? This one is a little bit different. Okay, it moves with a positive value in the first part, and it crosses the time axis and then becomes negative in the second part. So what do you expect about the motion of the car? So we can take a start to have a look together. Are you ready? Okay. And then it moves backward. The negative value means the car move in the reverse direction. Okay, it moves in one direction during the first 8 seconds, and then it change its direction of motion and then move backward in the rest of the motion. Okay, means positive, the motion to one side, and negative, the motion will be to the opposite side. Okay, for the last graph, okay, I think you can guess the motion of the car. Okay, I give you some times, and then you can take a pause of the video. If you have finished, then I click the start button. So it moves from 0 to 7 seconds, and then backward. Okay, wow, with a very, very high speed at the last part of the journey. Okay, so all these are the speed time graph of an object. Okay, so can you tell me what should be the graph look like for an object stay at rest? Yeah, stay at rest, that means it has no motion. The speed should be 0 all the time. So it should be a horizontal line which touch the time axis. Okay, so if an object has a graph look like this one, that means it stay at rest. How about this one? Okay, it has a non-zero initial velocity. At the beginning, its speed is not equal to 0. It is equal to a certain value. And then the object keep with this value all the time. Then we can say that the object move with uniform speed. The speed of the object is a constant. It does not change. Is it okay? So it is a horizontal line. It's still a horizontal line, but it is not at rest. It moves with constant speed. If the horizontal line touch the time axis, it represents the car move without motion. Okay. And for this one, at the beginning, the car travel with a small speed, and the speed getting bigger and bigger. The object move faster and faster. So we can say that the object has a speed which is increasing uniformly. That means the speed increasing constantly. We can say that it moves with constant acceleration. getting faster and faster. And obviously, for the last part of the graph, the object moves with a high speed at the beginning, and then the values become smaller and smaller. We can say that the speed decreasing uniformly, or move with a uniform deceleration. So all these are 4 typical speed time graph of an object: accelerate, decelerate, constant motion, and then at rest. Is it okay? And we have 2 special features can be found from the speed time graph. The first one is about the slope of a speed time graph. Do you still remember how to find out the slope of a graph or the gradient of a graph? Okay, if you forget about it, then we are going to tell you once more. Okay, for this graph, okay, it is not a XY graph, it is a VT graph. What is the physical meaning? What's the meaning for this value? So for this value, it is the speed of the object at time equals to 0. That means at the beginning. So it is the initial speed of the object, u. It is the initial speed. Is it okay? And the speed of the object increase constantly. And what is the physical meaning of this value? Okay, it is the speed of the object at time equals to t, or at the last part of the journey, the final speed. So it is the final speed of an object. Is okay? So the first point, the initial point, means the initial speed of an object, and the last point is the final speed of an object. Is it okay? And how to find out the slope of a graph? Okay, do you still remember? If you use the vertical height and then divided by the horizontal distance, it gives you the slope of the graph. Is it okay? And I want to ask you, what is the value of this vertical height? Right, it is equal to v minus u. How can we obtain this value? It is because the height of the blue line, the blue dotted line, should be v. And for this part, it should be equals to u. So for the red part, the red dotted line, it should be equals to v minus u. So it is the vertical height of the red dotted line. Is it okay? How about the horizontal length? Can you tell me the value of the horizontal length? Yeah, it is t minus 0. It is simply t. Is it okay? So from the ratio of the vertical height to the base length, then you can find out the slope or the gradient of the graph. So I use v minus u divided by t. Then this one gives you the slope of the graph. Is it okay? But take a look of the term on the right hand side. What are this term represent? V minus u, the final speed minus the initial speed. It means the change in speed divided by time. So if the change in speed divided by the time, it should be equals to the acceleration of an object. Is it okay? That means the slope of the VT graph, the slope of the speed time graph, give you the acceleration of an object. So if the question asks you to find out the acceleration of an object from the graph, so what should you do? You should try to find out the slope of the graph, and this one is equals to the acceleration of the object. Is that okay? And apart from this one, we have another quantity can be found out from the area of the VT graph. Let me give you an example. For example, if an object travels with 6 meters per second constantly for 10 seconds. Okay, the object start from 6 meters per second and then keep this speed throughout the journey for 10 seconds, right? So the graph will be look like this one. And then I want to ask you, what is the distance travel during the journey? Okay, if you have to find out the distance travel, then this formula will be useful to you, because the distance travel can be found out by the initial speed times the time plus half the acceleration times t squared, and so on. Okay, so let us put all the data into the equation and to try to find out the distance travel during the journey. The initial speed should be equals to 6, and the time taken for the whole journey should be 10. Is it okay? And what is the acceleration of the object throughout the journey? Because the object moves with constant speed, so no change in its speed, so the acceleration should be 0, no change in the speed. Is it okay? So you can ignore the second term on the right hand side. Is it okay? So the distance travel will be equals to 60 meter. 60 meter, right? And can you guess, how can you find out 60 from the graph? Yeah, some students will recognize that the height times the base length is equals to 60. So actually, the area under the graph, what it means by area under the graph, that means the area enclosed by the line and the time axis is give you the distance travel of the object. Is it okay? So if the question asks you to find out the distance travel by an object throughout the journey, how can you obtain this value from the speed time graph? You just simply find out the area under the graph. Then you can find out the distance travel. Is it okay? Okay, maybe this is the last part of this chapter. We are going to have a summary of all the important features that we learned from 3.1 to 3.4. Okay, from 3.1 we learn about the average speed. How to find out the average speed? It is the total distance travel divided by the total time taken. So it gives you the average speed of an object throughout the journey. Is it okay? But not all the objects travel with the same speed throughout the journey. It may be speeding up or slowing down. So if you want to find out how fast the object change its speed, then you have to find out the acceleration. Acceleration tells you how fast the object change its speed. So what are the terms on the right hand side? On the left hand side, A represents the acceleration, and V is the final speed, and U is the initial speed. So the difference of these two terms give you the change in speed divided by time. It means how fast the object change its speed. Is it okay? It is the acceleration. Is it okay? We learned all these two equations in 3.1 and 3.2. Maybe I want to draw some attention from you about U, V, and V average. If you want to find out the speed of an object at a particular time, at a particular instant, which equation can help you to find out the speed of an object at a particular time? Remember, don't use the first equation. The first equation only tells you about the average speed. It is not the speed at a particular time. If you need to find out the initial or the final speed of an object, you should use the second equation. Understand? So unless you have to find out the average speed of an object, Otherwise, don't use the first equation. Is it okay? And in section 3.3, we learn another important equation which helps you to find out the distance traveled by an object in a journey. So this equation is a bit long, but no worry, during the test or the examination, all these three equations will be given to you. But you have to know which equation you should use to solve the problem. Is that okay? So it is 3.1, 3.2, and 3.3. And in this last section, we learn about the speed time graph, or simply the VT graph, okay? And the VT graph, the slope of the VT graph gives you the acceleration of the object. So apart from calculation, from the equation, you can have another method to find out the acceleration of an object. And also, the area of a VT graph gives you the distance traveled by an object in the journey. Is it okay? Okay, I think this page is very important to you. You can take a pause of the video and then use a paper or a card to copy all these three equations and these two features, which can help you to solve the problem in this chapter. Is it okay? Okay, maybe we try to solve some problem, have some demonstration together. So please turn to page 6, question 1. Look at the question. Okay, the question shows you a speed time graph of a car. So can you describe? That means you have to tell the examiner, tell your teacher, tell your classmates, okay, what is the motion of the car. Is it okay? So how to tackle this question? How to answer this question? Look at the graph. So simply, how many parts you can divide the graph into? Right, it should be divided into 2 parts, okay? For the first part, okay, you should state clearly from what time to what time. So you can say in this way, from time equals to 0 second to 2 second. That means the first part of the journey. Okay, the car start from rest and then the speed increase uniformly to a certain value. Okay, so you can say that the car travel with uniform or constant acceleration. Is it okay? Don't forget to mention either of this term, okay? Uniform acceleration or constant acceleration. That means speed getting faster and faster and faster and faster. It's okay during the first 2 seconds. And for the last part of the journey, so you have to mention the time specifically from t equals to 2 to t equals to 6 seconds. For this part, it is a horizontal straight line. Okay, so you can say that the car travels with constant speed. Is it okay? So this is how to describe the motion of the car. You have to divide the graph into several parts, okay? For this question, for this problem, you have to divide the graph into 2 parts and then state the time clearly. Is it okay? Okay, how about question 2? Okay, can you do this question by yourself? Okay, you can take a pause of the video and then try to do it by yourself and then check with my answer later on, okay? Okay, I suppose you have done this problem, okay? So now we are going to show you the answer, okay? So how can you describe the motion of the graph? How many parts you will divide the graph into? Very good. It should be divided into 3 parts. For the first part, don't write down part 1. Okay, it is not acceptable. You should state the time clearly. From time equals to 0 to 2 seconds. Is it okay? That means this part. For this part, it is a horizontal line. So you can say that the car travel with constant speed. But what is this value? Okay, the graph show you this value. So you can state it clearly. The car travel with constant speed 20 meter per second. Is it okay? If you got all these words correct, then you can get 1 mark. Is it okay? And for the second part of the journey, it is from 2 seconds to 6 seconds. Is it okay? The car travel with, what is this one? Yeah, it is not accelerate. It is decelerate. And it is a straight line. So you should tell me the car decelerate uniformly or with uniform deceleration. Both are acceptable, okay? Decelerate uniformly, or the cars travel with uniform deceleration. And then to rest, because at time equals to 6 seconds, the speed of the car is 0. Is it okay? So decelerate uniformly to rest. If you forget these 2 words, add these 2 words to your answer. Okay? And for the last part of the journey, I think all of you can get the correct answer. Okay? So from time equals to 9 seconds, the car simply is at rest. Okay? Is it okay? So if you got all of these are correct, you will get 3 marks in the test. Is it okay? And for the part B, you have to find out the total distance travel. Total distance travel by the car. Okay, so you can take a look of the instruction on page 5. You can find out, okay, how to find out the distance travel of an object from the VT graph. It should be the area under the graph. So the distance should be equals to the area under the graph. So it is this area. So you can divide the area into 2 parts. For the first part, it is a rectangle. So how to find out the area of a rectangle? Okay, it is simply use the base length times the height, right? 2 times 20. And for the second part of the graph, it is a triangle. So I think all of you know how to find out the area of a triangle. It is the base length times the height and then divided by 2, right? Okay, so you can use your calculator to find out the value of this quantity, which should be equals to 80, right? But don't forget to write down the unit. What is the unit for distance? The unit for distance is equal to meter. Is it okay? Is it okay? It is not difficult. But some students may say that, Mr. Lu, your method is so stupid. I have a more direct method to find out the area under the graph. So how to find out it? We can consider this area as a whole figure. So can you tell me the name of this figure? Right, it is a trapezium. So how to find out the area of a trapezium? So you can use the top length plus the bottom length, right? And then times its height, and then divided by 2, right? So your calculation is simpler, okay? Then it should be equals to, right, 80, okay? So no matter which method you use, you will get the same correct answer. Is it okay? Okay, it is for 2B. And for the last question in this chapter, question 3. So take a pause of the video again and then do this question by yourself and check with the answer after you have finished. Okay, for question 3A, I believe all of you have finished doing this part, okay? It comes to the slope of the graph. the slope of this graph. Okay, some students may overlook of this question. Actually, there are two parts of this question. The first part is to find out the slope of the graph. You have to give me the value of this graph, and then to state the physical meaning of the slope. Okay, so there are two parts in this question. For the first part, how to find out the slope of a graph. Okay, I have told you before, but let us go over once together. How to find out the slope? You can choose any 2 points from the graph, but I suggest you to choose 2 points which are far away enough, okay, so that your answer will be more accurate. How to find out the slope of a graph? You use the vertical height divided by the horizontal length. So you have to draw a right angle triangle like this one. The vertical height and then divide it by the horizontal length. It will give you the slope of the graph. And what is the vertical height of this triangle? That means the vertical, the dotted line, okay? This point equals to 7, and this value is equal to 1. So this length should be equals to 7 minus 1. Is it okay? 7 minus 1. And how about the base length? Okay, this one, 1, 2, 3, 4, 5, 6, and then 7, and then 8. So this value is 8, and this one is 0. So the base length should be 8 minus 0. Is it okay? So the slope of the graph is not difficult. It is equal to the ratio of the vertical height to the base length of any 2 points. And I suggest you to choose 2 points which are far away, as far as possible, far away enough, so that your answer will be more accurate. Okay, so use your calculator. 7 minus 1 is equal to 6. 6 divided by 8 should be equal to 0.75. Is it okay? But not yet finished. What is the unit for the slope? What is the unit for the slope? There is a unit for the slope, okay? I want to ask you, what is the unit for the term in the numerator? That is 7 minus 1. 7 means 7 meter per second and 1 meter per second. So the unit for the numerator is meter per second. Is it okay? And the unit for the denominator is second. So meter per second is equal to meter per second square. Is it okay? So don't forget to write down the unit of the slope. Okay, and this is the first part of the question. How about the last part of the question? What is the physical meaning of the slope of the graph? Okay, if you remember it, then you can write down it should be equals to okay, of the object. But you can check it out from the unit of the quantity. The unit is meter per second square. So which quantity will have this unit? Right, it is the acceleration of the object. Understand? So the slope of a VT graph gives you the acceleration of the object. Is it okay? Okay. And for part B, what is the distance traveled by the object from 0 to 8 seconds? That means throughout the journey. What is the distance traveled? If you still remember, just like the question in question 2, it should be the area of the graph. So this area gives you the distance traveled by the object throughout the journey. Okay, so it is a trapezium again. So you can use the upper length plus the lower length, and then times the height, and then divided by 2. So 1 plus 7 and then times h divided by 2, right? Which is equal to 32 meter. Is it okay? For part B. Okay, for the last part of this question, okay, the last part asks you to find out the average speed, okay, of the object throughout the journey from 0 to 8 seconds. So, if you have to find out the average speed, which equation you should use? The first one, the second, or the third one? Yeah, it should be the first equation. The total distance traveled divided by the total time taken. Okay, from 0 to 8 seconds, what is the total distance traveled? Then this is the answer in part B. It should be equal to 32 and then divided by 8. The answer is 4 meter per second. Is it okay? But do you still remember I introduced another method to you to find out the average speed, okay, in one of the video, okay? The average speed can be found out in this way. Use the initial speed plus the final speed and then divided by 2. It is the average. Let's check out whether the answer is correct or not. The initial speed is 1 and the final speed is 7 and then divided by 2, which is equal to 4 meter per second. Is it okay? So you can use either of the formula to find out the average speed of the object. Is it okay? So here are all the demonstrations on page 6. So you have to finish the assignment 4, okay, and stay in the guidelines, okay. Please try hard and then enjoy the physics video. Okay, goodbye.